Good morning, children. Yeah, now we shall proceed with example problems. Here, one problem is 5 minus root 3 is irrational. We have to prove this. So, we'll go by that method of contradictory method. So, we'll take that 5 minus root 3 is rational. Okay, so let us solve it. So, what are we going to consider? Let 5 minus root 3 be rational. So we are taking it to be rational. If this is rational number, as per the definition, 5 minus, therefore 5 minus root 3 can be expressed in some a by b value. Very good. So therefore I can say that 5 minus a by b is equal to root 3. Now on transposing a minus b here. Or for convenience, let me write it as root 3 is equal to 5 minus a by b. Not an issue. Not necessarily you have to write this step. Not an issue. So now 5b minus a by b is root 3. So what we got here is, like taking the LCM here, 5b minus a by b is equal to root 3. What does it mean? So now let us observe the RHS. In the RHS, you have taken a by b is equal to rational number, isn't it? That means a and b are integers, and you know that this whole thing is a rational number. Right? When a and b are integers, 5b minus a is an integer, b is an integer. So this forms a rational number. So when RH is a rational number, right? Here RHS is rational. RHS is rational. Implies LHS must also be rational. Must also be rational. Is it not? So when you are saying that it is equal to, means whatever is RHS should be the same LHS. So here when RHS is rational, root 3 obviously must be rational. But this contradicts the fact, is it not? What fact? This contradicts the fact that root 3 is irrational. So in examples itself we have seen root 3 is irrational. So therefore, whenever this contradicts that root 3 is irrational, what we have assumed that 5 minus root 3 is rational is wrong. So absolutely it means that, so therefore our assumption that 5 minus root 3 is rational is wrong. Hence 5 minus root 3 is irrational. This is how you have to prove. 5 minus root 3 is irrational. Let's see what we did. See, we took the example problem here is to prove that or to show that 5 minus root 3 is irrational. What did we consider? We considered 5 minus root 3 to be rational. When it is a rational number, it should be expressed in p by q form. So we took it as a by b. So 5 minus root 3 is equal to a by b. By transposing a by b to LHS, we got 5 minus ab is equal to root 3. Okay. So then afterwards, just for convenience, I wrote it here on LHS side, root 3. Root 3 is equal to 5 minus a by b. Not necessary. Directly also you can do here also. 5b minus a by is equal to root 3. That much also you can write here all itself, right? So therefore I took the LCM, and so on LHS you have root 3, on RHS you have some rational number. So because these are all integers, thus this forms a rational number. Any number which is expressed in p by q form is a rational number. So now here RHS is rational, which implies that LHS should also be rational, because you can't equate an irrational number to a rational number. Since this is a rational number, even this should be a rational number. But that contradicts the fact. This is a fact. There is no need for us to prove it. Root 3 is an irrational number. So therefore it is contradicting the fact that it is irrational. So thus our assumption, whatever we have assumed, our assumption that 5 minus root 3 is rational is wrong. So therefore what is right? Hence 5 minus root 3 is irrational. So this is correct. Okay? So this is how you need to prove. Okay children? So pause the video for a moment. Take the screenshot and copy it down. And this part, the last part, this is how you have to write the conclusions. Alright. So now let us proceed to the next example. So here, prove that root 3 plus root 2 is irrational. Root 3 plus root 2 is irrational. So again we will take the same kind, that solution. We assume that let root 3 plus root 2 be rational. So we are considering, or we are assuming it to be rational. So whenever it is rational, what is the concept? So therefore root 3 plus root 2 is equal to a by b. So root 3 plus root 2 can be expressed as a by b. So now see the difference. See the difference from the previous problem. I'll go back to the previous problem once again. So in this problem you have only one root here. The other one is a non-root term. So therefore what did we do? We took the root term on one side and the non-root terms onto the transposed. We transposed the non-root terms onto the other side and we took the LCM and we brought it in the form of P by Q. And only one single root term was left on one side. So thus our discussion has become very clear. It has become very easy. We could conclude that this is an irrational number, but you are equating it to a rational number. So therefore our assumption is wrong. We could say this. But here, coming to this particular problem, you have two roots here, root 3 and root 2. That means two root terms are there. So therefore to solve this, the best method is that if we are left with one single root term, it will be easy for us to conclude. So what we have to do now? So we have to take the other root term onto the other side. So transpose root 2 onto RHS. So that will become a by b minus root 2. So root 3 is equal to a by b minus root 2. Okay, so now squaring on both sides. Let us square on both sides, right? So 3 is equal to a minus b minus root 2 whole square. So 3 is equal to a square by b square is a plus 2 minus 2ab, 2 into what is our a here, a by b, into what is the b, root 2. So we are left like this. So our concept should be only one root 2 term should be left there and the remaining all should be transposed onto the other side. So now let us see that one, how we can do. So transpose all these terms onto the RHS, right? 3 minus a square by b square. This comes here minus 2, which is equal to minus 2a by b into root 2. Minus 2a by b into root 2. So now let me take the LCM. 3b square minus a square minus 2b square by b square. Of course you can also 3 minus 2, you can do it as 1. So that is equal to minus 2a by b into root 2. Okay, so now 3b square minus 2b square is b square minus a square by b square, which is equal to minus 2a by b root 2. This simplification part, in whichever manner you want, you people can do it. Don't follow only this one. So bb will get cancelled here. So we are left with, now transpose minus 2a here. So b square minus a square by, so here it is multiplication, so it will become minus 2ab division. So that is equal to root 2. So what is that? So you can take minus common here, and you can write it as a square minus b square by 2ab is equal to root 2. This is what we got as a final equation. So how do we write the conclusions? We can write the conclusion saying that, so your LHS is again here is rational. LHS is rational. Right? So this quantity is a rational number. Right? That implies root 2 is also rational. But what is happening? But this contradicts the fact. But root 2 is irrational. But root 2 is irrational. This is a fact. It's a fact. So what we assumed here, that root 3 plus root 2 is rational, is wrong. So therefore root 3 plus root 2 is irrational. So this is how you have to write the conclusion. So therefore you have to write, so it contradicts the fact that root 2 is irrational. Therefore our assumption is false. Our assumption is false. Write a step here extra. Our assumption is false. Hence root 3 plus root 2 is irrational. Is that clear, children? So let us see. So what we did, root 3 plus root 2, we took it as rational. So therefore we equated it to a by b. So root 3 is equal to a by b minus root 2. Why did we take this one? Because squaring on both sides, only one particular root should be left. Hence we took, we squared on both sides. So it is different from the previous problem. Previous problem we didn't want to there is no need for us to take squaring on both sides. But here it is a must, because with two roots you cannot conclude it. You cannot sit and prove that again root 3 is this much, root 2 is this much, adding on this you are going to get this much, because these are non-terminating, non-repeating decimal values. So it is not an easy job to prove like that. Hence we take only one particular root. We solve this in a manner that only one root retains in the whole equation. So thus we are taking the square on both sides, and the simplification part is up to you. You can do in whichever manner you want. And but see that only one root term is left on any RH side or LH side. Remaining all things you need to transpose on to the other side. Thus we will be getting something like P by Q again. When it is a P by Q, so on one side of the equation, then that is a rational number. So, and then you are equating it to an irrational number. That means it contradicts the fact that it is an irrational number. Hence what we assumed is wrong. Hence root 3 plus root 2 is irrational. Okay children, so in your exercise also you will find two root terms in a particular problem, or one single root term. When it is a single root term, please remember, no need to square on both sides. You cannot come to a conclusion if you square on both sides. And if it is two root terms, that means there are two root terms, square root terms in a particular number, then you have to take a root on both sides and then retain a root on one side and transpose all other non-root terms to the other side. Okay children, so pause the video for a moment and then copy down. Take a screenshot. Okay, see, please try to complete your irrational numbers exercise and then post me, so that we can move on to the next part, logarithms.